Welcome back to another episode of the igus Classroom series. My name is Jan Hennecke and I'm the Product Manager for Low-Cost Automation here at igus. And today we want to compare traditional robotics with our low-cost automation approach. To showcase this, we prepared a video with a case study, which is a conveyor picking application. This is something you find in industry all the time. Basically, components are running down a conveyor belt, and the process goal is to take these objects from the conveyor belt and place them into some sort of box or a shipping container. On the left side, you see the traditional robotics approach. On the right side, you see the low-cost automation approach. What we see here is a typical conveyor picking application. Parts come down the conveyor belt and have to be picked into a box. The traditional approach uses a delta robot because it can pick really fast, integrated with a camera system that is locating the components. Now, the system is expensive because you use a very fast robot, but also a camera system that is expensive, and then the integration to put everything together. The total cost typically in our case study comes down to 100,000 euros or $100,000. Now let's compare this to our low-cost automation approach. When we talk about low-cost automation, the first step is to break a process down into individual steps, thereby simplifying the requirements for each individual step. Over here, you can see 3 different steps. The first step is a mechanical alignment feature. Parts are coming down the conveyor belt and get aligned right there mechanically. Sensors will sense if objects are there to talk to the other 2 robots and initiate the motion. We thereby eliminated the expensive and complicated camera system. In step 2, you can see a pusher down here that will basically, whenever we determine that there's 4 objects on the belt, we'll push these objects to the side and hand them off to step 3, the linear robot that then takes 4 objects at a time and places them into the bin. Now, taking 4 objects at a time is actually a simplification because we can reduce the individual speeds of the robots themselves. Instead of having to pick 4 times, we can just pick 4 at a time. That allows us to use robots that are not as fast as the Delta robot and therefore not as expensive. In total, this project is easy to set up, and in combination with the low-cost hardware, but also the easy integration services that we provide with igus that allow you to integrate yourself or with simple help from us, allow us to bring the project cost down to $10,000 or euros in this case. Let's look at how we solved this problem in our own factory. Again, the low-cost automation approach looks at the problem and figures out how to break it down into the most steps possible. So here on the right side, you can see the infeed where the metal components slide down onto a separator table. On that separator table, you have a mini camera working together with the gantry system that will then pick up every single one of these sliders, look at the orientation, and then place them down into a gantry. Now, instead of one robot arm that just picks this out of a bucket, we have many little steps. But this allows us to use hardware that it doesn't have to be very precise, doesn't have to be very high payload, and doesn't have to be very quick. Here you can see how the sliders were separated, picked, put in the right orientation, and now they get put in this form. Basically, there's one robot picking it up, placing it into the hands of another robot that then rotates it by 90 degrees, and a third robot picking those four sliders and placing them down into the machine, as you can see here. So it sounds counterintuitive. Instead of using one robot, we use 3 robots. But because those robots don't have to be with very high specs, they're actually much more affordable than the whole system themselves and easier to integrate. This is just one example on how we use low-cost automation to automate our own factories, breaking complex processes down into individual steps and then checking what robot do I really need to achieve that goal. I hope this was helpful to you. I want to thank you for tuning in to another episode of the igus Classroom series. If you have any questions, feel free to reach out to myself. You can go on igus.com or rbtx.com or book a free video consultation with our RBT experts on rbtx.com. Have a great day. I hope to see you soon for another episode of the igus Classroom series.